Okay, in this introduction video, we are going to learn about motion. And so we're going to learn about scientifically how do we describe objects that are in motion. So one thing to talk about when we're doing science is really there's different types of quantities in science. We have things that are numbers, which are no units. We have things that are scalars, which are numbers with units but have no direction. And then we have numbers that are vectors. They're numbers that have to have both units and direction when you talk about them. So like 2 is a number. 2 meters is a scalar. 2 meters south is a vector quantity. Okay? And so sometimes that, whether we're talking about a number, scalar, or vector, will just kind of vary slightly like what we have to do. When we're talking in science where something is and how far it's moving, we use 3 different terms, which we went over in class. So we just need to make sure that you understand these different terms and how they're related to each other. So a lot of times for position is with respect to a reference point. So we need to make sure that when you're talking with somebody, you understand where their reference point it is that they're measuring to. When we're measuring something's, we're talking about when we use formulas, oftentimes most formulas work in displacement. Even though a lot of times we're more interested in distance. Distance and displacement equal each other whenever you don't turn around. Okay? When we're talking about how fast something is moving, then we're talking about its velocity. So when we're talking about, or speed, the only difference between speed and velocity is speed is relating our distance to our time traveled, and velocity is how our displacement per amount of time traveled. And we can talk about average or we can talk about instantaneous. So let's say I'm driving from Janesville to Mankato, and I don't remember exactly how far this is, straight line, but let's say it's we'll say 25 miles. Okay, that's the distance between those two. If I drive straight there, that's also my displacement. Let's say it takes me 25 minutes to do this. So then if I take and divide that out, I'm going 1 mile per minute. That if my distance and displacement are the same, then my speed and my velocity are the same. Just one I have to put a direction in. If instead I took some back roads from Janesville to Mankato, and I don't know if there's any back roads that actually do that particular route, let's say now I went 50 miles. Okay, so now I went 50 miles, and let's say I did that in still 25 minutes. Okay, so here if I do 50 miles in 25 minutes, my speed would equal 2 miles per minute. But because I'm still going from Janesville to Mankato, my displacement is the same, and so my velocity would be 1 mile per minute. So velocity doesn't, your average velocity does not depend on the route. Your speed always depends on the route. Okay? Another term we need to get familiar with and get comfortable with when we're talking about how things are moving is acceleration. Acceleration is the rate an object's velocity is changing. When you accelerate, you can either be changing speed or you could be changing direction. So accelerating could be speeding up, it could be slowing down, it could be turning. So in your car has 3 accelerators. The gas pedal speeds you up, the brake pedal slows you down, and the steering wheel turns you. So all 3 of those could be thought of as accelerators in terms of science. Okay? So if we look at this diagram, if we have the car here, if it turns but keeps the same speed, it's accelerating. If it speeds up but keeps the same direction, it's accelerating. If it falls off the cliff, it's both turning and speeding up, it's accelerating. If it suddenly comes to a stop, that's also accelerating. Okay? When dealing with all different types of motion, there's some equations here that are going to become very useful to you in this class, and we're going to work with how do you use these equations to solve motion. So here they all are written for you. So either write them down in your notebook in a place that's easy to access, or make sure you have this sheet printed out so that you have them somewhere, because you're going to be using them a lot, so you're going to want to be able to look at them. Okay? So what we do whenever we're solving problems, and we'll work on solving more problems in class, is there's some steps we need to do. The first step we do is we make sure we understand what information do we have. So as I read through this problem, a car is moving at a constant speed of 10 meters per second for 5 seconds. So that 10 meters per second, that's important. That's a speed or velocity. Either way, we represent it with v. And then if I'm going for 5 seconds, that's a time. And they want to know what distance. So that's what I'm trying to figure out. So if I got my distance is my unknown, my time is 5 seconds, my velocity is 10 meters per second, I look for what's an equation that uses those three things, d, v, and t. So I go back and I go, okay, this one does. And so I'm going to use that equation. Then I can plug in the numbers I know. I don't know d, I leave it as a d. I know v is 10 meters per second, and I know t is 5 seconds. So seconds cancels out, I'll be left with an answer meters, which is the unit I want for distance, and my answer is 50 meters. So that's the process for solving problems. Okay, we're going to do some more in class, so you can have these like already go if you printed them out, or we'll do them together. Okay. The next thing I want to talk about, and we saw this already in class, is when you are graphing motion, you get some different types of graphs. So again, if you're stopped, that means your position isn't changing, your velocity is unchanging. You can be stopped anywhere, so position versus time graphs of stop is just a horizontal line anywhere, whereas a velocity versus time graph is a horizontal line, has to be at 0 because your velocity is 0. If you're moving with a constant speed, it means your position versus time is changing in a very constant way, so that is a sloped straight line. So the blue one would be moving away from your reference point, the green one is moving towards your reference point. For velocity versus time, if you're moving at a constant speed, your speed is constant, so you get horizontal lines, but this time not at 0 because you have non-zero velocities. Again, blue is away from your reference and green is towards your reference. If you're accelerating, that means your speed is changing. So the slope of your line is changing when your speed is changing. So you have a curve. The blue line in this case would represent speeding up away from my reference point. The orange line would represent speeding up towards my reference point. And the same thing, velocity. These are color-coded. Okay. You could also slow down, and I don't know why I didn't put those on, but if you're slowing down away, it's going to look like that blue line. If you're slowing down towards, it's going to look like that. If you're slowing down away, you're going to have a line that looks like this one. If you're slowing down towards, it would look like that one. Okay? So we can use this to piece together a story of what our motion looks like. So as I look here, for this first bit, my object was stopped, then it sped up, moved at a constant speed, changed its speed, slowed down, remained stopped, sped up backwards, moved backwards, slowed down backwards, sped up backwards, moved at a constant speed, slowed down and stopped. Okay, so we're going to be working on how to piece together a story by taking those different segments from, whoops, not there, taking those different segments from this page and trying to put those together with some different shaped graphs. Okay, so here to try to match up, like you have position versus time and velocity versus time. I think we'll do this together in class. Okay, but see if you can figure it out here, like which position versus time graph and which velocity versus time graph tell the same story based on, are they talking about like being speeding up, slowing down, what have you. Okay? So again, that's just an overview. We will work through this stuff in class to start with real quick, and then once it seems like people have a handle on it, then we'll just give you, here's your worksheet, and away you go.